Hi, this is Dr. Ian Brown. From here on out, I'm just going to go by the name DocCopemys. That's why my username here, Facebook, Twitter, a couple other places. With this series of videos, what I'd like to do is share some of the techniques that I use in my own research. I use a lot of photogrammetry to make 3D digital models of fossils. And I've also gotten into using tools that are available in local makerspace at the public library to make little bits of equipment that I use in the lab. And it occurred to me as I was working with these things that some of these might be of use to other researchers. They might be of use to artists, these techniques, people who want to make a 3D model of something they see in their environment. So I thought I'd put these out there, just little tricks on equipment, using different bits of equipment, using different pieces of software, some that are freely available, some that are not, and just tips and tricks that I have found useful in my own research and as an artist. So, little history about me. I have a PhD in biomedical science. I currently am a postdoc teaching gross anatomy to first year medical students and working on research. If you have been to the Society of Vertebrate Paleontology meetings the past couple of years, you may be familiar with my current research where I've gotten sidetracked a bit into developing techniques to make photogrammetric models of fossils that are very small, um, 0.5 to 2 millimeters long. Eventually, I'll give some tutorials on how to do that, both on YouTube and maybe some blog write-ups. But for right now, I'm holding off on that until I get the papers published. But today, what we're going to do is just kind of a very simple introduction. This is the rock that actually got me interested in fossils initially when I was 15 years old. My mom found this when she was a teenager. She rediscovered it when I was a teenager in our shed as she was cleaning it out and asked me if I thought it was a fossil. And for the life of me, it looked like a piece of bone and a piece of rock. So I took it to my anatomy teacher and he said, "Yeah, that looks like a fossil." He took it to the Raymond M. Alf Museum. They looked at it and said, "Nope, that's a rock. It's just a piece of chert that looks like a fossil." But it's special to me because this is what got me fired up thinking about geology, fossils, paleontology when I was a teenager, and this is why I majored in geology and then went on from there. So what we're going to be using today is just a very simple point and shoot digital camera, anything similar to types of cameras many people would have. I could have actually used the camera on my cell phone. That would produce photos of equal quality, but I was actually using my cell phone to shoot the time-lapse video you'll see in a second. So to create a model using photogrammetry, the first thing we need to do is position the object, and in the time-lapse you'll see me take a little piece of clay. I have, excuse me, I have some green paper laid out on a table. That's just to make it a little bit easier to um, edit out the background once we have a point cloud. I'll take a little piece of clay, stick it to the bottom of the rock, just to make a little stand for it to sit on. And if you get it so that you're taking the photos at an angle where you don't see that clay, it'll essentially appear to float above whatever your background is. That will make it a lot easier to edit out any parts of the background that may still be in the point cloud once it's generated. Because what we'll do is we'll do that, we'll flip it over, take a bunch of pictures with a specimen in this angle, orientation, this orientation, and on the edges. It'll take about 5 minutes to shoot the pictures that I need. So it's a very quick time lapse, shooting 1 frame every second.
So here you can see I'm simply taking a bunch of pictures from all sorts of angles, reorienting the specimen, adjusting the clay underneath it that's supporting it, and just trying to get as complete a coverage as I can before I move on.
Okay, now that we have the photographs, we need to load those into the computer. We're going to use VisualSFM to build a 3D point cloud. VisualSFM is a freely available program that was developed by Chang Wu as part of his PhD work. Now, it's freely available for research purposes or personal use, but if you're wanting to make models to sell these things, do something along those lines, you will need to inquire about a commercial license. I've been meaning to do that just so I can tell people in the documentation. He says for commercial licenses, please inquire. Just haven't gotten around to it. That said, there are other programs you can use. There are quite a few. I actually also use Agisoft Photoscan. For some things, I prefer VisualSFM in my own research. VisualSFM is a great program. It's actually pretty complex in that there are a lot of things you can do with it. You can tweak a lot of settings, make it do some very specific sorts of things. But at a basic level, what we're going to be doing today, it's not much more than put your photos in, press this button, let it run, press this button, let it run, press this button, let it run, and then save. So I'll walk you through that, and we'll get a nice point cloud that we can then take into MeshLab, where we will make a watertight model that is texturized and also get that ready for 3D printing and some other bits of software. That's probably going to be another video or two. I don't want this to go too long, but I do want you to get through making a point cloud today in this introductory video. So let me bring this down. And this is VisualSFM. So I'm just going to go to File, Open Multiple Images. This takes me to folder where I have all the photos that I shot in that time lapse. Just hit Control All. Oops. That was my rock on the table. Control All, open. That is actually bringing up something that was hidden underneath. So what you're seeing here, it's opening the images, loading them into RAM, and now it's just working on generating the thumbnails that we'll see on the screen in a second here. When I tried this data set earlier, I think it took about 20 seconds, 25, 30 seconds. It's pretty quick. Won't take too long. Pause it just for now. Okay, so it took a little bit longer than I thought it would. 48 seconds. You see we've got 86 images of that rock. Let's see, shot from this angle. You can see it's sitting on its side. If you zoom in and look at these, you can see that that clay that it's sitting on is not visible in any of the images. And so what that gives you is a little bit of a gap. That'll be very useful later in editing out any of the background that winds up in our point cloud. So the first thing we want to do, we've got them all in. We're going to go up to this icon right here, Compute Missing Matches. Looks like a little X with arrows on the ends. You click that. It starts identifying points within each of the photographs. So as it's working through each of the photos, you see this number here in this column. That's essentially how many unique points the algorithm thinks are present in that photograph. And then that's the amount of time that it spent on each photograph, picking out those points. Works through those pretty quickly. You see where, okay. Now we get into actual feature matching, and what it's doing is it's comparing two sets of photos and then trying to see how many points are present in one photo, how many of those same points does it identify in another photo, and then it creates a matrix of information between those, then compares to other photos and tries to identify those same points and gets that information. Then from there, it does a bunch of math in the background, figures out where the camera is in 3D space once we start building the point cloud, and then it will, once it knows where the cameras are, put a point in three-dimensional space, and we'll get a nice point cloud. Now this is going to take a little while. You can see in each of these matches, 34 matches, 46, 94, 30, 32, 98. So we let this run. I'm going to press pause, and then we'll move on to the next step when it's done. Okay, so we're back. You see that it took just over 19 minutes to do the feature matching on the photographs. So once that's complete, you go to the next step, in which we click this icon right here, which looks like two little arrows next to each other. This will actually build our sparse point cloud. This is pretty fun to watch. Starts putting up some points. Expand the cameras. Whoa, and it failed. Let's try that again. Okay. Well, it looks like we're getting a little bit more advanced lesson today than I had anticipated. Sometimes what happens is you'll have a good set of photographs and they'll fail because the initial pair of photos that the program has picked out as the initialization pair don't have a good match between them, and it just falls apart. Okay, so following that little hiccup, I went in and manually set the initialization pair for model building. That was a little bit more complicated than I wanted to get into with this introductory video, but for those who are interested, I shot a little video of what I did. It's pretty easy. You just go in, select the photos you want, run through a couple of settings, and through trial and error, you repeat that process until it works. But right here, we're just going to move on as if we had not experienced that little problem. So once all your feature matches are done, you go up to this little icon that looks like two arrows. You click on it, and it starts to put points in space. You can see each of these here is a camera that it's kind of positioning in space and then throwing up the related points. To increase the size of the points, you just hold down the Alt key and use the scroll wheel on your mouse if you want to make those larger. To zoom in, you just use the scroll wheel on your mouse. Rotate, you hold down the right button on your mouse and move it around. You can see very quickly it built our sparse point cloud. I really like watching the clouds build. That's my favorite part of this. It's kind of relaxing.
If you want to increase the size of your photographs so you can see them, you hold down Control and use your scroll wheel. You can bring them down to points, or just so you can kind of see how they relate to your model. I usually leave them a bit like that. So then what we do is we have our sparse point cloud that could be used to generate a watertight model in MeshLab, but it's not going to have a ton of detail. And so what we want to do is generate a dense point cloud. And there is a piece of software that's sort of integrated into VisualSFM that does that. It's actually a separate program. You click on the button and it sends the data to that program. There are directions on Chang Wu's website how to implement that. You can also use some other programs. Some other users of VisualSFM use other programs to do dense point clouds. But all you have to do with this is click on this button, CMVS. It brings up a folder to put it in. I'm going to go into here. You need to give it a file name. I'm just going to call it pseudofossil2, or just pseudo2. Click save, and then it starts working through the data set. The first thing it's going to do is undistort the images. And so it takes your initial photos, tweaks them a little bit, and puts these copies in another folder. And you can see it's renaming those images. Now we'll actually use these images when we go into MeshLab later to make our watertight model when we're putting a texture on it, generating a texture. So I'm going to let this run through and get to the next part, and then we're going to press pause and stop for a while. Okay, so it's finished adjusting the images, and then it gets to this part where it says this may take a little more time, and this is where it's actually starting to generate the point clouds. This will take a while. On this machine, it's going to take somewhere between 45 minutes and an hour. This is a pretty fast machine. It's a gaming laptop. The machine I had before this was a very standard sort of office net surfing, nothing fancy, no graphics card, and it would take quite a while. This is the sort of thing that, depending on how fast your machine is, you might want to start it before you go to bed and let it run overnight, or depending on how many photographs. The more photographs you have, the longer it's going to take. But for the most part, even if it takes a long time, it does a good job of working through. It doesn't crash all that often. But what I'm going to do is stop this, and this button here, this little pause button, will stop that. I could actually exit out. Let's just exit out, because what I've done is run this earlier, and much like they do on cooking shows, I am pulling a finished dense cloud out of the oven right now, so to speak. You can see that ran for a total of just over 49 minutes to generate this cloud. This is what we're seeing is the sparse cloud that we saw before, pretty much the same thing. And if we go in and hit the tab key, our dense cloud comes up. So holding the right mouse button down to rotate, you can see we've got the points of our dense cloud. Gives a pretty good representation of our object. And you can see here we've got some of the background still coming through, but because there is a nice gap, because we left that clay so it would float a little bit, once we get into MeshLab we can just select these points easily and delete them. So this is not a bad dense point cloud. Some of the proprietary paid software that's out there will actually generate a much nicer dense cloud. I'll often use that in my own work. But I wanted to show you something that could be done with software that's freely available that anybody could get. Using a camera, you could use the camera on your cell phone. If you've got a point and shoot, you could use that. If you've got a SLR, digital SLR, by all means use that. That'll produce much nicer photos. But pretty much anybody could go out today, load up VisualSFM, and generate a point cloud. So from here what we'll do is we'll take this into MeshLab, where we'll take this dense point cloud and we'll generate a watertight surface. From that, we will then create a texture over the surface that will give it a much more photorealistic appearance. And that'll be nice for if you wanted just a digital model to put on a screen, you know, whether it be your iPad, your computer, put it online for something, you can manipulate it that way, manipulate it in the screen, do whatever. Or you could also take that watertight surface and take it into a slicer for a 3D printer and get it ready for 3D printing, which we'll do with some other projects down the road. But in the next video, we will take this into MeshLab and make a model.